All right, so how does a reverse iterator work? So let's see. I mean, we have, what is the underlying state? So remember what we want to do. We want to do we basically want to say print range something, something else, right? And here's the line we had written. We're going to create this reverse iterator object initialized with end, and another one initialized with begin. We give it to print range, and we expect it to print our array in reverse order. Right? So our problem now is how do we implement reverse iterator? Right? And we looked at when we designed the basis, remember what were the fundamental operations? You needed some underlying state, and you need to know how do I dereference and how do I increment. Those are the three questions we have to answer. Right? So what is the underlying state? Underlying state is a pointer, all right?
Well, but let's think about it. Do we want to make it work for the pointer or for something weaker than the pointer? Observe that what he wrote here, he didn't write reverse iterator of int. He wrote reverse iterator of int star. That should give you a clue. What is the requirement? This is a template, right? Reverse iterator. Is it a template? Yeah, I mean, clearly a template. There's an angle bracket after it. So it takes some type, yes? What's the requirement for this type? What kind? I mean, iterate. Is there such a thing as iterator? Forward iterator? Forward iterator. So it cannot be forward iterator. Why couldn't it be forward iterator? Because you want to go backward, and forward iterator, by definition, is the one which goes only forward. So what kind of iterator? Bidirectional iterator. Thank you very much. In order to be able to go backwards through the range, you need to be able to go backwards. All right? You have to. But if this is any iterator, here's go forward. But this iterator, in addition, because what are you trying to do? What's the whole idea of this adapter? Tell me the idea. Never mind C++. What's the idea in English? What's the idea more specifically? What do you want to do? You have an interface. What do you want to do with the interface? You know, this is like you connect pins, you connect this pin with this pin. What do you want to do? But this is an iterator. You know nothing about data structure. This is just iterator. It has some operations. What do you want to do? For example, you need to implement iterator operations out of this iterator. But what's the idea? The most fundamental idea is what? It's very simple, guys. You want to swap Jack. What do you want to swap? Logically. Direction, meaning you want to swap which operations? And minus minus. You want whatever is minus minus to become plus plus. And what was plus plus to become minus minus. You want to change somebody, didn't pay attention. Thank you. You wanted to say, you want to change the direction. Right? So it's an adapter which changes the direction. Right? So I'll say one more thing. There is obviously a trivial solution. It's the wrong solution. You'll say, I'll just take the iterator, this iterator which points to this, and all the operations like dereference is the same, equality is the same, and plus plus becomes minus minus, minus minus becomes plus plus, right? Sounds great. Huh? Doesn't work. Why doesn't it work? They have to answer. We cannot go further, any further till they get that. Why is it wrong? It's a very tempting thing.
Because our begin is not end and our end is not beginning.
Can you
No,
explain
that's all
that
right.
further?
No,
What do you
but
mean
for
by
the
that?
iterator, no. For the iterator, it doesn't matter. Iterator knows nothing about our end, our begins. It doesn't know. Why wouldn't it work? There's a fundamental mathematical, not C++, mathematical reason why it doesn't work. It starts and ends on the wrong elements. No, but it starts and say these are the elements 1, 2, 3, and this 3, 2, 1. Uh-huh.
So if plus plus gives me the lesser value, it breaks the computation.
No, why? I mean, you know, the direction of pointers in memory, it's an arbitrary thing. Who knows what they are? There is profound mathematical reason, guys. We discussed it again and again and again and again. And not one of you could answer. How do iterators work? How all the algorithms structured? And they have to be structured. They take how many iterators? Two. And are these two iterators symmetric? No. We have semi-open range, and we discussed many, many times why we have to have semi-open range, because we want to deal with empty range, multiple reasons.
End on the process. So you start on end, you can't dereference end.
You cannot dereference end. Okay, but another problem is that there might not be a guy before the beginning. You see we have these two guys? But there might not exist this guy.
Just like there's the guy that ends points.
No, this is, problem is deeper
but
than
at
that.
least the pointer exists. The value of the iterator exists. But there might not even be a value of the iterator here. Might not exist. Yeah? No, it just...
No, it's worse.
No.
On a bidirectional iterator, when you're at the begin, I mean, minus minus is not even meaningful.
Because, I mean...
Maybe you're at the beginning of a linked list. I mean, minus minus
there
does
is
not
no
make sense.
previous. What is previous? There's no previous. Right? But here you have to observe this beautiful symmetry, mathematical symmetry. If you have a range like that, here means semi-open range which includes the first but does not include the last, you could easily map it to a open, semi-open range like that. By doing what? What's the transformation which maps from this to this? Simple. Thank you. It's -1. Its predecessor goes from here to here. If you consider that this value points to its predecessor, then it immediately becomes this. Show them on the
Another way to
picture.
think about this is that in the regular forward iteration case, what do we have? We have 3 positions here that we want to reference. And how many values of the iterator do we have? We have four values of the iterator. We have 1, 2, 3, and this thing that doesn't point to anything. So we have 4 values of the iterator. Now in the reverse iterator case, how many positions do we have? We still have 3 positions. How many values of the iterator do we have? We have 4 again. So we have enough values of our iterator for the reverse case. All we need to figure out is we have only 4 values. We can't make up new values because our requirement says this is a bidirectional iterator. Plus plus over here is not defined, minus minus here is not defined. So we have 4 available values to us. Now the question only is which of the values we use in which positions, right? That is the only option we have. We have only 4 values to work with, right? And then of course the question sort of answers itself in that, well, if we have these, then this is the underlying state we will use when we want to refer to this thing, and this is what we use when we want to refer to this. This is what we use when we want to refer to this, and this is what we use as the termination point. Because there is no other what else would you use as a termination point? Right? So you just shift everything over 1, and then it all works.
Except you shift the other way, sort of. Or whatever, you could, elements, yes.
Depends on the direction.
Which one you shift, the first row or the second row.
Yes, right? So now that we know what we want to do, we can write the code for it, right? So I copied the previous one just so that we could save time here. So we have a bidirectional iterator. We already discussed the underlying state is the value of the iterator, right? What is the value type? The value type of the iterator. So I'm just going to write that. Value type of I think this will work. Reference pointer we don't need to change, I believe. It just what we should really do is we should write.
It's reference of I.
Reference of I, and for pointer we should write pointer of I.
And you have, except you'll have to define type functions.
They're defined.
They're defined? Good.
Difference type is correct. This will be a forward iterator.
By the way, why difference type is correct? I know that you know, but why is it the same type? Well, because what does it do? It measures the distances this way. And what I claim, if type is sufficient to measure the distances this way, it's certainly sufficient to measure the distances the other way. Right? So just.
And let's make it a bidirectional iterator. I think it's straightforward to do.
No.
No?
No, it's wrong. This is wrong. Again,
We
why
could
is
make
it
it a
wrong? By the way,
bidirectional
why is it wrong?
We could make it a bidirectional iterator.
We could, but it would be a terrible design. Why is it a terrible design, guys?
Because it only goes backwards, it doesn't go forward.
No. Okay, I give you a pointer to this adapter, and you return and you tell me now you have bidirectional iterator. You lie.
You don't lie.
You lie because what you really should have is, if you change direction on pointer, does it have random access? What do you think?
It doesn't.
Of course it does.
Well, okay. So you want
Oh,
to
it's
make
a
it random.
pointer.
If I promise less than the existing, I'm not lying. I'm just saying I
No,
only
but you are
promise bidirectional.
breaking all kinds of things. Because here, what the task, the intent of this thing is to change direction. You could have an adapter which restricts the interface, which takes random access iterator and makes it into, say, forward iterator. Could you write such an adapter? At least Ryan can. You just, do not provide any other operations except for plus plus. Yes? But this is not our intent. Our intent is to take a direction.
Yes.
So
we
what
can-
should it be? It's trivial. Yes.
basically, Alex is
Of
saying we can
course.
do whatever the underlying iterator is, we can provide the same power in reverse.
Yes. Whatever it does, it does.
So let's do that. I would first do a forward and then I would generalize, but that's
you cannot
fine.
do forward.
Of course you can do forward.
No.
You just don't
cannot
define
create.
decrement and
No. I mean, this, you would do forward iterator where? As a requirement
no,
on
as,
I?
a, as
or-
the iterator category. I can say that my reverse iterator.
No, but this is
adapter-
enormous. I mean, you see, for example, I don't know whether you remember, but we actually tried the following thing. You could take reverse iterator, this rend and rbegin, and pass it to sort.
Absolutely.
And what happens, by the way? Anybody knows what will happen? If you have a bunch of numbers, 3 to 1, and you sort it with reverse iterator, what will happen? It should be, and what is reverse order? It has a name. What is the default order for sort? Instead of ascending order, which is default, it will be decreasing order. Yes, that's what it will do. It will just work. It does. I'm not making it up.
Yes. I agree.
It just changes directions.
Yes.
The point of reverse iterator is not to restrict, but to change direction. This is why.
I agree.
Okay.
So let's do increment and decrement because they're really easy. What's increment? Minus, exactly. I think we've covered that. And what is decrement? All right. And what's offset? And what's difference?
That's a tricky one.
It's the same.
Is it? Is it? Think about pointers. What is the difference between this pointer and this pointer? 2. What's the difference between this pointer and this pointer? Now, if we have reverse pointers, what's the difference? You change directions, my friend. Change direction has to flip the side, doesn't it?
Okay.
No, it's not a convention. It's must.
So we just flip the minus around. That works. Now we get to a complicated one, which is deref. How does deref work?
Didn't we have some code there?
Yes, I deleted it.
Oh, you deleted. But
You have to make a temporary of the position and go back one and then dereference that.
Okay, so I say, can you tell me?
no, okay, fine. There is no -1 for
Equal position
bidirectional iterator. For random, yes.
minus
Bidirection, no.
return start time.
Yes. I think that will work. And we can try it. Should we try it?
Well, this, of course, you could have one line less.
Using your beloved.
Okay. You guys are too tough for me.
Reverse iterator is reverse iterator basis of I. All right. So let's. Oh, I didn't spell it out completely. Never mind. I'm going to truncate this. Let's try printing. And if we get printing to work, we can try sorting, which will be really exciting.
And if sorting works, then anything else works. Sort of.
Yes. Of course.
What happened?
I didn't change all the types. Over
Which types?
Here, this one.
Oh, I see.
Perils
Yeah,
of
yeah,
cut
yeah.
and paste. Yes.
Zero.
Yes.
R begin and R end.
What about Arbigin and Rn?
Still have them.
Nope, I fixed it. I fixed it. Yes. compiles. And
It even works.
it works. All right. Now we can try sorting and see if the random access part works.
Use random shuffle first.
Random shuffle. Oh.
Just to make it more impressive, because sorting sorted array, some of our
no, but
audience might.
it's sorted in increasing order.
But if you do random shuffle, it takes no time. Just write whatever you.
But it is not in order. It is not in order.
What do you mean it's not in order?
It's in increasing order, and we're going to sort using a reverse
No, but
iterator.
if you just put a line here, it will become so much more compelling.
Fine. If you think so, std random shuffle.
Random shuffle, yes, and begin end.
Begin of x1. Okay, so we shuffle it, we print
Shuffle it, print it,
now let's
print
sort.
it from, and then. Oh, you could keep, well, yeah.
This should sort it in reverse order. And then we can print it in order to see what we get.
Yes.
Sounds good?
Sounds beautiful.
Compiles. And
Yes.
random, reverse sorted. So it works.
It works.
Okay, so we have reverse iterator. But I mean, the thing to note is, remember we spent that day last time writing this really painful class. But now that that is done, the rest of it just works. So it's very helpful to try to extract out the essence of what you're trying to do, because doing that lets you do these things in half an hour, which would otherwise have taken you God knows how long, because there are a dozen or more operations in the entire iterator interface, right? Do you want to talk about why reverse iterator exists?
Now let me talk about what
Go ahead.
reverse iterator exists. Once upon a time, there was a language called Common Lisp. Some of you might remember. Well, Hernan is watching soccer, so Nicholas remember. Okay, so, and that was the first language which attempted to do the following thing. It attempted to factor out some fundamental operations on sequences. And in Lisp, there were two kind of built-in sort of data structures. There was linked list with cons, car, and CUDA, and there was a vector. There was sort of data structure, pretty much like STL vector, logically speaking. And then they introduced sequence algorithms. And obviously, I learned quite a bit from them, but I learned both positive things and negative things. Like I learned from what they did, and I learned from what they didn't do, and from what they did wrong. So let us look a little bit at that. So they observed the following things. They said, oh, you could have something like a position. Seems to be independent of the data structure. So they said position will take a data structure with a vector list and will return. What should it return? Position. Position is not a value type. Position. You are looking for something which sort of is the fifth position, the sixth. Yes, and so they did. So you're looking for something, for a good person in a list, and it returns you a number. So what's wrong with that? Isn't it a good interface?
Hard to go back from number to position.
In a linked list, think about it. So if you basically return something which is sort of pointless because you will have to do literally the same number of steps to get back to that. But they had no choice because they did not know about overloading. Or they did, but they thought it was a bad idea. Sort of, it's thinking about that I realized I have to return different types. Different, if you like, iterator types. One type for a vector, which will be like a pointer to a vector, or could be an index into a vector, that's all right, it would work. But I would have to return a const cell or pointer to a node for a linked list, because that's what makes sense. So I have to return different, that the notion of algorithm which does position, of course, would require me to return different types which depend on the data structure. They have to share some properties. They all should be iterator-like things. But on the other hand, they could be different.
I mean, if you look at the machine, it's all a pointer underlying, but the
Plus
operations
is
on it are
different.
different.
Plus is just adding one for an array, and it's dereferencing in case of linked list. That was the first insight. But then they were good people. These were solid people. They said, oh, but sometimes you want to use this sequence operation on a subsequence. So they say, we'll introduce keyword argument begin end, which tells you where to start. By the way, what things they should take for begin and end. And again, they were stuck with the same problem. These, they said, oh, they will be indices. Does you much good for linked list. Think about it. Again, you give indices, you have to charge here, you have to charge. It's just awful. Yes? So, but that was the design. They had to unify. And I had to face that. So how do I allow you to use algorithm on a part of a data structure? That's why iterators again come from. That if I suddenly realized that I could solve that problem by starting with an iterator, wherever it points, not necessarily in the beginning, and wherever it ends, well, modular, past the end of where it ends. Right? And that would allow me to solve this problem, provided I have overloading. But another thing which I learned from them, and that was they also allowed you to go backward. And it's often useful. Of course, in their case, going backward on a singly linked list spares the thought, but you know, it could be done, by the way. Anything could be done, but it's awfully expensive. It's quadratic, of course. But they had no complexity consideration there or in many other places. So, but it was a very important thing which I sort of learned. I say many algorithms make sense if you do them backward. And what I did in the first design of STL, many algorithms had a version which says something foo underscore backward. By the way, there is still one there which remains. Anybody knows? Not you know, you know, but any of you know? John? No? Copy backward. Very good. Very good. Great. It was supposed to disappear, but you see that the guardians were not watching carefully. So, because you could find backward, does finding backward make sense? Yeah, you go from the back. Or, you know, many algorithms which you sort of adjacent find, whatever, you could do in backward direction. Makes perfect sense. So my idea was to have this underscore backward. Is it a bad idea? I actually don't think so, because if you do it uniformly, that is, for any algorithm which you define, you provide, if backward makes sense, you provide a version, it's perfectly fine thing to do. But here comes Bjarne, that we had a meeting at HP Labs to sort of adapt whatever I had so that standard committee would accept it. And the main thing Bjarne wanted was to reduce the number of things. So if he was just saying, could we cut this, could we cut this?
I mean, as it is, STL was huge. If you look at books, C++ books from 2003, often half of it would be STL. Like,
Yes,
you know.
but it was bigger. So lots of things were, and then we get to this backward algorithms. And what happens is Bjarne says, no, this is not acceptable. We have all this, couldn't you have the same interface and then do something? Well, I could do anything, you know, all of us could do anything. So that's where reverse iterator came from, is idea of changing backward to an adapter which will run algorithm backward. Right? So I'm still not convinced that, practically speaking, it's so good. And I do not remember the story. I could make it up on the fly, but I'll not. Somehow copy backward remain there. Maybe because it's used all over the place, or I convinced Bjarne, maybe I have no recollection actually. Or I convinced Bjarne that this one is really helpful. By the way, when is copy backward? Why copy backward is so important for regular copying? Anybody knows? Overlapping ranges, great. You see, if you want to copy two overlapping, could you draw please? Two overlapping ranges. They overlap. Now, let us assume that you want to copy second into the first. What would you write? You would write std copy, right? It will just copy. Would it work? Yeah, works perfectly fine. However, let's imagine you want to copy first into the second. Will it work? It work a little bit. It will work halfway.
You'll copy the first few, but then you will obliterate this, and therefore, you know.
So this is the problem, that depending how you copy.
But if you copy backwards, you'll be fine, because whatever you're overwriting is something you will never read again.
Everybody sees so. Copy backward is a very common. By the way,
Isn't it also the reason for this is because there are different assembly commands to do both, and so the underlying implementation can actually be different for the two.
no. The underlying implementation actually happens to be, don't forget, you cannot use assembly language. Why couldn't you use assembly language? Tricky question. Why couldn't you? It worked for arbitrary T. Assignment has to work as defined for T. Assembly language, sadly enough, knows nothing about it. And it is. But the primary thing working for arbitrary T has to be written in terms of just assignment for T. Right? So this is a very important case. So, yes?
So I have a question for you. This is just my curiosity.
Sure.
But there's one very unintuitive thing about STL, which as you use it, it becomes obvious why it's done. It's not obvious when you first look at it.
Huh.
And that is what you referred to earlier, which is that the end is one pass.
I spent 20 lectures in this room explaining this. Let us explain why. Yes. Huh?
What I want to know is, at what point did it become obvious to you?
It became obvious to me because what was the language I was programming before C++? I mean, what's the story of STL in terms of, did I do it? Everybody said, oh, he did it in C++. But anybody who wants to sort of look at my code, you could see the same code appeared before that in another language called Ada. And before that appeared in a language called
Lisp.
Scheme
Scheme.
in particular, right?
Was there a C version as well before it, after Ada and before C++? There was a C version.
There was a C++, but almost C version in between STL and Ada library. But I obviously had a bunch of algorithms implemented in Lisp. And in Lisp, You always have past the end on linked lists, guys. Null is always there. There is always a position which has no value. It's past the end, yes? So that was very natural. Then I had to write a generic library in Ada because I got lots of money from, I was a poor assistant professor, and a large militaristic company was giving me huge sum of money to do it in Ada. And, you know, assistant professors do anything for money. Look, you know, I was literally hungry. I wanted money. Plus, they don't pay you over summer. So they pay you something till like May, but then for 3 months, you have to eat grass. So I had to do Ada. I didn't want to eat grass. So, and in Ada, they had this amazing thing. You could have an array indexed by an integral type, an array with n elements, indexed by an integral type, listen carefully, containing n elements. Like they said, you could have an array which sort of goes from 1 to 1, 2, 3, and this data type on which it's indexed will contain values 1, 2, and 3. And that was dreadful, guys, because the moment you try to write something simple, like find, you realize you cannot even write it. I mean, it's all right if you find it. There's something to return. But if you don't find, there is no value to return, because the data type of index has 3 values. And I was horrified. And you could look, I mean, we published a book describing all of that, my friend Dave Master and I. And we had to always extend whatever this return iterator with this boolean, which tells, are you past the end or not? You had to extend the type. So that's how I discovered, like, really, I cannot do algorithms. For example, you do partition of n elements. So how many partition points? With 3 elements, you have 4 partition points. You have nothing. So you have to. It was dreadful. So, and then I joined Bell Labs because they basically hired me and said, oh, he did this for Ada, he could do it for C++. So they hired me to Bell Labs, and the first week into it, or the second week, very early on, I have a meeting with a bunch of guys, including Andy Koenig. There's a person called Andy Koenig. And I explained to them this terrible thing about Ada. And I said, well, we have to deal somehow with it. And Andy Koenig looks at me and says, C has no problem like that. I say, what do you mean? He said, in C, it's guaranteed that any array has a pointer defined past the end. That was apparently the requirement which they figured out when they were doing ANSYS. I tried to figure out who actually came up with this requirement. Maybe Larry Rossler, but I'm not sure. Okay, I think Larry Rossler told me that he did it, but I don't have independent confirmation. One thing you learn that in computer science, every time you ask someone a question, who invented it, the person, I did. It's not, I'm not questioning his veracity. I am questioning that I do not have written sort of some evidence. Like Knuth always attributes things to his next door neighbor, like all the algorithms are invented by von Pratt. He never says I invented it. He always says von Pratt invented it. Whatever you ask him for some unknown algorithm, he says von Pratt, which I suspect means that he sort of, the default is von Pratt. If the neighbors don't know, then von Pratt. So whether, but I doubt it, because on at least one case, when he said von Pratt, I know who actually did. And it wasn't von Pratt. So going to this past the end. So Andrew explained to me, Andy Koenig, that for every array there is a pointer. Mind it doesn't mean this pointer could be dereferenced. Computer could melt down if you attempt to do that. But at least the value is there. And that for me was just this wonderful thing. I realized that whatever I was suffering from in both, like I was suffering other issues with Lisp, then I was suffering with Ada, C solves that. That the model of iterator called pointers is the correct, this is good thing. That's what I could use for iterators. Did I answer your question? Yes. Okay. So it goes through, I understood the need for that before C++. I understood that I could do it in C, and I could modify all the interfaces to return just the iterator. And it will indicate not found, or partition point is past the end. Everybody satisfies the predicate. During that conversation with Andy Koenig, for which I am eternally grateful. So in general, my understanding of what I call C machine, there is this abstract machine C defines, comes from Andy Koenig. He explained it to me because I did not realize how it worked. I tell you a great secret. I was hired to do C++ libraries at Bell Labs, algorithmic libraries, but I didn't know one simple thing. Not even that, worse, C. I did not know C or C++. So I assumed that I could learn, and I could. So this is why when people concentrate on language questions during interview, I think it's very stupid. I don't care if I hire, say, Jack, whether he knows C++ or not. He either can think or he cannot. But if he can think, he could think in whatever language. If he cannot think, tough. So, long time ago, I was very young. I had a friend who was a Swedish diplomat in Moscow, and he refused to learn Russian. Which sort of a strange position if you spend many years in the middle of Moscow. I mean, you might as well learn it. But then he always would sort of explain it by saying, a fool is a fool in any language. So, which is true, guys. Actually, learning a language doesn't make you smart. And this is why I remember when we were starting a course, I was saying, languages do not matter. Right? Sort of this is, okay. We have a few more minutes. Let me tell you other similar things which happen because they're also instructive. Remember Common Lisp? We just talked about it. In their sequence library, they also figured out that many algorithms had multiple versions. For example, if you have find, you have a version where you have a sequence arranged. Right now, let's just postulate a semi-open range of iterators. And you could find, what is the simplest thing? What could you find? A value. That's the simplest thing. So you should have find, which takes a value and finds a value equal to it. Okay? This is a perfectly solid good thing. Find 3 in the, from here to there. Good. Then they had three versions. For example, if it is this kind of find, if you find 3, you could do the following thing. You could replace equality logically with some other binary relation. Could you? It makes perfect sense. For example, you should be able to say, find 3 less than. So find the first element less than 3, or greater than, or divisible by 3. Or not equal to 3, for example. Yes, absolutely good question. So we want to have this version, yes? And then we need another version. Absolutely need another version. Which version do we need? Some arbitrary predicate. You just look at this and so there are 3 versions of find. And they're sort of, what I tried to do, no, sorry guys, and these guys, common Lisp guys, also observed that sometimes you have this nice way of saying find if divisible by 3. But how do you say not divisible by 3? And they come up with an idea that you could have a version which negates the predicate. So my original solution, let me tell you how it was like that. Again, to provide, and these are legitimate functions, by the way. These are all very useful and need to exist. You cannot just say, well, you don't have to provide all of them. One way or the other, people use them. So you have to provide something. So my original solution was, again, using suffixes. I was going for every version would be just a different name. So find if not. And by the way, we have another suffix already. Find if not backward. So, but I told you what happened to backward. Backward was, yes.
What was the name for the general predicate?
For the find if, same as now.
But you need one more, right? One that takes a value and a relation.
Yes, but that is less general than find if. And that is still in STL. All of them are still in STL in one way, shape, or form. In STL, find takes optional fourth argument, which is a binary relation. So the find in general, the most general form is begin, end, or first, last, value, relation. And relation defaults to equality, to equal. Make sense? Okay. But then, of course, who comes? Bjarne comes. Bjarne comes. No. All Andrew at that point somehow just takes this position that he will not work with me on improving STL. He will just answer my questions. And he was extremely helpful. But he's not proactive. But because Bjarne, Bjarne is such a major figure that nobody wants to interfere when he is on the move. So, and Bjarne on this mission to cut the interfaces. So there's too many finds. So we get rid of backward, introducing reverse iterator. And then he wants to get rid of not. And here comes this horrendous thing, which again some of you might know, is std not 1 and not 2. Anybody knows? This is good. But there are things in STL, and there are probably better things now in new STL. But the original thing was try to provide a negation thing, which will take a predicate and negate it. So you say, if not divisible, it will be not divisible, if you see my meaning. So I had to introduce a bunch of these adapters. And you could say, oh, this is so very clever. Well, but that unleashed, you see, doing these adapters, I unleashed something which, again, you have to know that if you do something, the consequences could be not what you expect. So people looked at STL and said, oh, this is so very cool. You could hack templates, and they could generate things. So people started writing adapters. So reverse iterator, is it a good thing? Yes, it's a good and useful thing. But it possesses one negative thing. What's the negative thing about reverse iterator? It's actually absolutely correct. Don't look at the semantics. Semantics is wonderful. But there is something profoundly disturbing about it.
It doesn't point to where it gets the value from?
Oh, it does point to where it gets the value. Now, then, don't look at the semantics. Semantics is right. It has to be like so, mathematically. There is one problem. The problem is there is a bunch of code relatively large. Could you show us implementation of reverse iterator
The original
before the original? It's a huge piece of code, like that. Don't show, I'll just,
I mean, you
Like
can
that.
imagine, right? You take
it's
this and
that. You have to
expand
do,
this into the
and
full
there's
iterative
plus,
class.
equal, minus, equal, you know, all these things you have to define. Yeah, it's like that. What does it do? It does nothing, guys. That's the astonishing thing. This is an example of code which does nothing. It doesn't do anything. There's just some gobbledygook, but it doesn't do anything. There is no code. I mean, it doesn't generate any assembly code.
I mean, it's an adapter, right? So by definition, it's useless by itself. There's some underlying algorithm that you've written that is doing the work, but this is just fluff.
And this is just fluff. This is just fluff. And that is the problem. Why it's a problem? It's not a problem occasionally write an adapter. You have to. Maybe I had to. I'm not saying. And reverse iterator is useful and it's mathematically sound. But the whole idea that you write a lot of code which does nothing is very dangerous. Once upon a time there was a Windows system called X. Some of you might have heard. X. And at some point Ken Thompson looked at it. And his reaction was, this is the largest bunch of code which does nothing. Because you look at X Windows and there's just lots and lots of code which does this callback, does that callback, which does that callback, which does, right? So it creates, and a lot of some of you who know object-oriented frameworks, all these factories, anybody knows about factories? So if you look at code written in terms of these object-oriented frameworks, or what are they called? Design patterns. And you see lots of code, and you observe the remarkable property. It doesn't do anything. They're just patterns. They're just things which do nothing. And I am responsible, this is an example, of starting this other evil thing, sort of meta-template programming. Everybody, instead of writing code which does things, started writing meta code which doesn't do things, which says, let me show you how you could implement factorial if instead of integers you will use templates, or instead of integers you will use data structures. Could you do it? Yes, you could do just about anything. But when the point of programming turns into meta-programming, when there are specialists in meta-programming, when people start concentrating on that, that becomes evil. Right? Sort of one of the important things which I try to, there will be a concluding lecture next week and I'll be talking about, but one of the most important things I try to tell you, it is about algorithms and data structures. It's not about languages. It is not about metaprogramming. Right? It's sort of, this is at least my opinion. So you have to know these techniques, but use them very seldom. So how often do you need to write your own adapter? You usually don't. Try to write correct algorithms. Do not concentrate on adapters. That I just, since we taught you something, I have to tell you, but it's not, that's not what programmers should be doing. Right? And in many respects, it is my fault that we wandered into this land of sterile programming, writing adapters. You cannot, think about it. If people were just producing connecting wires instead of boxes which do something, not much good will happen in the world. You need boxes. Yes, you need Blu-ray box and television. Yes, you need a cable which connects them. But it actually shouldn't be the center of your work. The center should be Blu-ray and television. So just something I wanted to say. I did want to say.
No, I think it's important to say.
Yes.
Because all of these techniques are, they're very easily misused.
Or if you
Go down this path.
concentrate on them, This is true, and this is, again, some of you know that I criticize object-orientedness, like John is aware of that. But again, what I'm criticizing is that it's form over substance. It's the same thing for this template programming. The moment you start concentrating on that, you're on the wrong road. The 99% of the code which you write should be algorithmic, and 1% you could do that. I'm just trying to point to the ratio. So, and generalization is good, but good algorithm is more important than generalization. Start with good algorithms. We'll get to it again. I'll have to preach for 2 hours,
right.
but I will be in India.
Yes, I will not be here next week, but I'm sure Alex will handle
Yes.
the class admirably.
Well, as before, guys, you're not going to see anything different. But I'll give a summary. The point will be try to give a summary of what we tried to teach and failed. I have been teaching now since I started teaching early 70s, like around 1970. So lots of years. I never taught well. It's impossible. You could never teach anybody anything. But you have to try nevertheless. So, see you next week, guys.